March 17, 1943, Medellin, Tunisia. General Major Hans Kramer lifted the captured field manual from his desk, its olive drab cover still bearing American insignia. His weathered face, marked by 2 years of desert warfare, twisted into something between contempt and amusement. "Look at this," Kramer said, tossing the manual across to his operations officer, Oberst Werner Marx. "The Americans call this contraption their workhorse. Soft steel, rubber tracks, open-topped like a touring car." Marx nodded, his fingers tracing the technical specifications. "Maximum armor, 12.7 millimeters. Our standard anti-tank rifle punches through double that thickness." Oberstleutnant Friedrich von Broich, the division's intelligence chief, set down his coffee with deliberate care. "We shouldn't dismiss it entirely. The production numbers in the latest intercepts suggest they're manufacturing these at unprecedented rates." But Kramer waved him off with the confidence of a man who just helped destroy 31 American tanks at Kasserine Pass. "Production means nothing when the product is inferior. At Kasserine, we destroyed 52 American tanks with only 19 losses. At Sidi Bouzid, we eliminated 98 American armored vehicles for 47 of our own. At Fade Pass, the ratio was even more favorable. 112 American vehicles destroyed for 31 German losses." He gestured toward the window where captured M3 half-tracks sat in neat rows under guard. The mathematics were undeniable. American equipment was second-rate, produced by a nation that understood commerce but not combat. What Kramer didn't know, what none of them could have known as they catalogued another American defeat in that dusty headquarters, was that the M3 half-track would transport more Allied soldiers to victory than any other vehicle in history. The numbers would become staggering. 41,000 M3 half-tracks produced by war's end compared to Germany's 3,000 SD, KFC, 251 half-tracks. American plants would manufacture 137 M3s daily at peak production. The factories would build more half-tracks in 6 months than Germany produced in 6 years. The mockery in that Tunisian headquarters would become history's most expensive miscalculation, measured in the 192,000 German soldiers who would surrender in North Africa 2 months later, transported to captivity in the very vehicles Kramer had dismissed as inferior. The German confidence in North Africa rested on tangible victories, not propaganda. At Kasserine Pass, February 14-22, 1943, Kramer's division had helped inflict catastrophic losses. 6,100 American casualties, 183 tanks destroyed, 208 artillery pieces captured, 500 other vehicles eliminated. The kill ratio stood at 2-6-1 in Germany's favor. At Sidi Bouzid, February 14-15, the numbers were even more brutal. 4,400 American casualties, 98 tanks destroyed, 57 half-tracks eliminated. At Fade Pass, the experienced Afrika Korps had demonstrated tactical mastery. 112 American armored vehicles destroyed for 31 German losses, a ratio of 3-6-1. Equipment specifications reinforced this confidence. The German SD, KFZ, 251 half-track mounted armor ranging from 8 to 14.5 millimeters, carried 12 soldiers, reached 62 kilometers per hour, and featured a front-mounted MG-34 or MG-42 machine gun with interlocking fields of fire. German engineers had refined the design through 6 years of continuous warfare across Poland, France, North Africa, and Russia. Each vehicle represented 186 labor hours of precision manufacturing at Busingen AG, Hanomag, or Deutsche Werk facilities. The Maybach HL-42 TUKRM engine delivered 100 horsepower with Germanic reliability. Track width of 330 millimeters, distributed weight efficiently across desert sand. Recent American failures provided additional confirmation. At Kasserine Pass, inexperienced American crews had abandoned serviceable M3 half-tracks when German tanks appeared. Intelligence reports documented 47 M3s captured intact, their crews having fled without firing their inadequate 50-caliber machine guns. The M3's 12.7 millimeter armor couldn't stop even German small arms fire at close range. The vehicle's open top exposed passengers to overhead artillery bursts. Its gasoline engine created catastrophic fires when penetrated. American soldiers called it a Purple Heart box, a recognition of its vulnerability that German intelligence found both amusing and strategically significant. Kramer's own combat record justified his dismissiveness. He had commanded armored reconnaissance in France, where his units had covered 320 kilometers in 5 days, outpacing French defensive responses. In North Africa, his mobile formations had executed the kind of warfare German doctrine perfected: rapid maneuver, concentrated firepower, exploitation of breakthrough. At El Agheila, December 1942, his reconnaissance elements had identified the weak point in British positions that enabled Rommel's counteroffensive. At Mareth, his units had screened the main assault force, identifying minefields and strong points with methodical precision. He had earned the Knight's Cross not through luck, but through professional competence in mobile warfare. Von Broich's concerns rested on harder data than Kramer appreciated. The intelligence officer had been tracking American production figures since Pearl Harbor. In December 1941, American factories had produced 0 military half-tracks. By June 1942, monthly production reached 416 units. By December 1942, 853 half-tracks rolled off American assembly lines monthly. The February 1943 intercepts suggested production exceeded 1,000 units monthly across multiple facilities. Von Broich had calculated that at current rates, American half-track production would exceed Germany's entire war production of all armored vehicles by August 1943. He had presented these figures to Kramer twice. Kramer had filed the reports without comment. Hauptmann Klaus Dietrich, commanding the reconnaissance company that had captured the M3 half-tracks at Kasserine, confirmed their apparent inferiority through first-hand experience. "We engaged 7 M3s at 800 meters, Dietrich reported. All 7 were destroyed or abandoned within 4 minutes. The vehicles had no defensive capability beyond a single machine gun. Their crews exposed themselves when manning weapons. The thin armor fragmented under high explosive rounds, creating secondary casualties inside the vehicle. When we examined captured examples, we found poor welding, rough machining, hasty assembly. These were commercial products rushed into military service, not fighting vehicles designed by professionals." Dietrich had commanded reconnaissance vehicles since Poland. His assessment carried the weight of combat experience across 4 years and 3 campaigns. The mathematics seemed irrefutable. German half-tracks required 186 labor hours to manufacture, ensuring quality. American M3s required just 92 labor hours, suggesting corner-cutting and inferior workmanship. German vehicles used superior steel alloys, carefully heat-treated. American vehicles used commercial-grade steel, inadequately processed. German production emphasized quality over quantity, 3,000 SD, KFZ. 251s produced between 1939 and 1943 represented careful allocation of limited industrial capacity. American production emphasized quantity over quality. 14,000 M3s produced in the same period represented the kind of wasteful manufacturing that prioritized numbers over combat effectiveness. The German approach concentrated resources on proven designs. The American approach scattered resources across multiple inferior variants. Professional analysis supported professional judgment. American equipment was second-rate. The American machine. Detroit, Michigan, January 1942. Edward Stettinius, Jr., stood in the White Motor Company plant watching the assembly line produce its first military half-track. The single facility would ultimately produce 21,000 M3 half-tracks before war's end. Every 48 minutes, another vehicle rolled off the line at peak production. The pace would accelerate as workers mastered procedures and management optimized workflow. By May 1942, the plant produced 1 M3 every 43 minutes. By September 1942, every 38 minutes. By December 1942, the Detroit facility alone manufactured 119 M3 half-tracks weekly, more than Germany's entire monthly half-track production from all facilities combined. Production progression followed American industrial logic rather than European manufacturing tradition. In January 1942, America produced just 78 military half-tracks monthly, split between multiple experimental variants and limited production runs at scattered facilities. By May 1942, production reached 416 monthly as standardization enabled mass production. 4 facilities contributed to this output. White Motor Company in Cleveland producing 206 units, Auto Car Company in Ardmore producing 87 units, International Harvester in Fort Wayne producing 75 units, and Diamond T Motor Company in Chicago producing 48 units. By September 1942, Monthly production exceeded 853 units as additional facilities converted to military production and existing plants expanded capacity. By February 1943, American factories produced 1,274 M3 half-tracks monthly. White Motor Company alone was producing more half-tracks than the entire German war industry produced of all armored vehicles. This single facility was producing more than the combined output of Büsing NAG, Hanomag, Deutschwerk, Borgward, and Adler, which together represented Germany's entire half-track manufacturing capacity. Dorothy Thompson, previously a department store cashier from Toledo, now operated the main welding station on hull assembly. Her station produced 47 complete hull welds every 8-hour shift, each requiring 14 minutes of precise torch work following standardized patterns marked on templates. She produced more welded hull assemblies in one shift than the entire Büsing NAG facility in Berlin produced in 4 days. The comparison wasn't hyperbole but mathematics. Büsing NAG's maximum daily output reached 3 SD, KFZ, 251 hulls requiring 8 welders working overlapping shifts. Dorothy's single station, replicated across multiple American facilities, demonstrated the transformation of warfare from craft to industry. She had received 4 weeks of training. Her welds passed military inspection at 97% first-time acceptance. The templates eliminated the skilled judgment that German welders spent 3 years apprenticing to develop. American engineering converted expertise into procedure, eliminating the craftsman bottleneck that limited European production. James Washington, from Birmingham, Alabama, operated the transmission assembly station that produced 18 complete powertrains per shift. His single station's daily output exceeded the entire Hanomag facility in Hanover, which produced 4 complete Maybach transmissions daily using 14 skilled machinists. Washington had operated textile looms before the war. The machinery at his station cost $47,000, 3 times his annual peacetime salary for 8 years. The automatic indexing system positioned each component for assembly without requiring the spatial judgment that made European mechanics valuable. He installed 43 components per transmission following color-coded sequences painted on the assembly fixture. Each complete powertrain took 26 minutes to assemble. The station operated 18 hours daily across 2 shifts. The mathematics were straightforward. One semi-skilled worker using American machinery produced the same daily output as 14 skilled European craftsmen using traditional methods. American industry hadn't matched European quality. It had rendered European quality irrelevant through volume. William Knudsen, $1-a-year man from General Motors, managed the conversion of automotive production to military manufacturing. He had spent 40 years building cars using interchangeable parts, standardized assembly, and continuous improvement. The same principles applied to half-tracks with modifications for military specifications. The White Motor Company plant in Cleveland represented the transformation he orchestrated. A facility that built commercial buses in 1940 now produced 62 military half-tracks weekly using the same workers, the same building, and assembly methods refined through 30 years of automotive manufacturing. Knudsen had eliminated bottlenecks European manufacturers accepted as inevitable. German half-track production required specialized machine tools, dedicated facilities, and workers trained in specific military manufacturing techniques. American half-track production used commercial automotive tooling, converted existing factories, and relied on workers who learned military assembly as a minor variation of commercial practice. Americans discarded 6,300 pounds of steel daily as scrap from the Cleveland facility alone. The shavings, rejected stampings, and machining waste represented more raw steel than Germany allocated monthly to the entire SD, KFZ, 251 program. The White Motor Company sold scrap steel to secondary processors who recycled it into rebar and commercial products. German manufacturers collected every metal shaving for remelting because allocations were calculated to the kilogram. At the Hanomag plant, workers swept floors 3 times per shift to recover metal dust for recycling. At White Motor Company, janitorial staff disposed of metal dust with other industrial waste. The waste from this single American operation exceeded Germany's total capacity for specialty steel production allocated to military half-tracks. Workers threw away cutting tools after single shifts that Germans resharpened and reused for months. A carbide cutting bit cost $47. At auto car company's Ardmore facility, machinists discarded 280 cutting tools weekly, replacing them with fresh tools that maintained precise tolerances without the skilled judgment required to compensate for worn cutting edges. The discarded tools retained 70% of their usable life. German machine shops issued cutting tools to individual workers who maintained personal sets for entire careers, developing intimate knowledge of how worn tools cut differently than fresh ones. American facilities treated cutting tools as consumables, accepting $47 costs per tool rather than employing the skilled workers necessary to maximize tool life. The tools that one American facility discarded weekly would have equipped 3 German manufacturing plants for a year. The cafeteria at International Harvester's Fort Wayne facility discarded more food daily than the Busing NAG workforce in Berlin received monthly through military rations. The Fort Wayne cafeteria served 8,000 workers across 3 shifts, providing unlimited coffee, subsidized hot meals, and free fruit. Daily food waste exceeded 1,000 pounds, uneaten portions, expired ingredients, preparation waste. The Busing NAG workforce of 2,300 workers received regulated rations calculated to the gram. 200 grams of bread, 40 grams of meat, 15 grams of fat, supplemented by whatever employees could obtain through private channels. The Fort Wayne cafeteria's weekly waste totaled 7,000 pounds of food. The Busing NAG monthly allocation for all workers totaled 4,800 pounds. American industrial abundance manifested in coffee grounds that represented more calories than German war workers received as meat rations. Rejected aluminum castings from Diamond T's Chicago plant could have built Germany's entire half-track production for 1943. Quality control rejected 6% of engine block castings for minor porosity that didn't affect function but failed acceptance standards. The rejected castings went to scrap dealers for remelting and sale to commercial manufacturers. Each rejected block contained 43 pounds of aluminum alloy. Weekly rejections totaled 1,800 pounds of aluminum, 8% of Germany's total monthly aluminum allocation for SD, KFZ. 251 production. German facilities used castings with minor porosity after inspection confirmed structural integrity. American facilities rejected marginal parts because the economic cost of field failures exceeded the material cost of scrap. German industry optimized for material conservation. American industry optimized for reliability without material constraints. The mathematics demonstrated different industrial philosophies. German manufacturing assumed scarcity, American manufacturing assumed abundance. Von Browich documented these production figures in monthly intelligence summaries filed with Oberkommando der Wehrmacht. His March 1943 report noted that American half-track production from October 1942 through February 1943 totaled 5,346 vehicles, exceeding Germany's entire war production of SD, KFZ, 251s. His report calculated that a single American facility, White Motor Company's Cleveland plant, produced more half-tracks in 5 months than all German facilities would produce in 1943. His analysis predicted that by June 1943, American monthly production would exceed Germany's total war production of all half-tracks. The report arrived at Kramer's headquarters on March 15, 1943. Kramer filed it with previous intelligence summaries. 2 days later, he stood examining the captured M3 half-track with dismissive confidence. The mathematics of German tactical superiority seemed more relevant than the mathematics of American industrial capacity. Superior soldiers using superior equipment didn't lose to inferior soldiers in inferior vehicles, regardless of production numbers. Quality defeated quantity. Professionalism defeated amateurism. Experience defeated industrial output. The reasoning was logical. The conclusion was catastrophic. First contact. March 23, 1943. Marath Line, Tunisia, 8:47 hours. Hauptmann Klaus Dietrich was repositioning his reconnaissance company when the American infantry assault materialized from depression terrain that maps showed as impassable for vehicles. At 8:47 hours, his forward observation post reported vehicle movement. At 8:49 hours, the first M3 half-tracks crested the ridge line carrying a full infantry squad each. Dietrich counted 17 vehicles in the initial wave, moving in dispersed formation at 35 miles per hour across terrain his own vehicles couldn't traverse at half that speed. The American vehicles didn't slow for rough ground. They maintained formation through obstacles that should have forced individual route selection. At 8:51 hours, his lead SD, KFZ, 222 armored car engaged the nearest M3 at 600 meters with 20mm cannon fire. At 8:51 hours and 43 seconds, the M3 returned fire with its 50 caliber machine gun while continuing to advance. The round struck Dietrich's command vehicle, killing his radio operator. Elapsed time from engagement to first casualty, 43 seconds. At 8:52 hours, Dietrich's company engaged with all available weapons, 3 SD, KFZ, 222 armored cars, 2 SD, KFZ, 232 heavy armored cars, 4 SD, KFZ, 251 half-tracks. German doctrine called for reconnaissance elements to identify enemy positions and withdraw. American doctrine apparently called for reconnaissance elements to charge through enemy positions and continue advancing. At 8:53 hours, 17 M3 half-tracks disgorged 170 American infantrymen who immediately assaulted German positions with overwhelming fire superiority. At 8:55 hours, Dietrich's lead SD, KFZ, 222 was destroyed by American artillery that had been called in during the approach march. Kill time from first spotting to vehicle destruction, 8 minutes. At 8:56 hours, his second SD, KFZ, 222 was destroyed by concentrated 50 caliber fire that penetrated the thin upper armor. Kill time, 9 minutes. At 8:58 hours, American infantry overran his forward observation post. Elapsed time from initial contact to loss of forward positions, 11 minutes. The engagement lasted 23 minutes. German losses, 2 SD, KFZ. 222 armored cars destroyed, 1 SD, KFZ. 232 disabled, 1 SD, KFZ. 251 half-track captured intact, 12 personnel killed, 17 wounded. American losses, 0 vehicles destroyed, 3 personnel wounded by shell fragments. Kill ratio, 2-0 in favor of forces using supposedly inferior equipment. The ammunition expended in this 23-minute engagement exceeded the monthly allocation for an entire German reconnaissance battalion. American forces fired approximately 14,000 rounds of 50 caliber ammunition, 240 rounds of 75mm artillery, and uncounted thousands of rifle rounds. German doctrine allocated 6,000 rounds of 20mm ammunition monthly per reconnaissance company. American forces had expended more than double the German monthly allocation in less than half an hour while advancing continuously, not defending fixed positions. Dietrich survived by ordering immediate withdrawal at 9:03 hours. His after-action report reached Kramer's headquarters at 1400 hours the same day. The American vehicles demonstrated capabilities inconsistent with previous assessments. They achieved speeds exceeding 50 kilometers per hour across broken terrain. They maintained tactical formation during movement. Infantry deployed under fire and immediately assaulted prepared positions. The combination of vehicle mobility and infantry aggressiveness created overwhelming local superiority before we could establish defensive positions. Request immediate reassessment of American half-track capabilities and doctrine. The report included precise timing, vehicle counts, and casualties. It noted that captured American soldiers from the 1st Infantry Division reported that their units had trained for 3 months on M3 half-track operations, learning to dismount under fire and assault immediately, converting the vehicle from transport to assault platform. Kramer read the report twice, compared it to previous assessments of American tactical incompetence, and concluded that Dietrich had encountered an anomaly. Isolated tactical success doesn't indicate systematic capability, he wrote in the margins. American forces remain inexperienced and their equipment remains inferior. One aggressive attack doesn't reverse the strategic situation. He filed the report with other after-action summaries. Von Browich retrieved it that evening, read the engagement timeline carefully, and cross-referenced it with his production intelligence. 17 American half-tracks had engaged a German reconnaissance company and achieved tactical surprise through speed and aggressiveness. American factories were producing 137 M3 half-tracks daily. The mathematics suggested an uncomfortable conclusion. If Americans could produce 17 half-tracks for every 1 German SD, KFZ, 251, and if those American vehicles proved tactically effective despite material inferiority, then German forces would face systematic numerical disadvantage in every engagement. 17 American half-tracks today, 137 tomorrow, 4,000 monthly. The numbers represented an approaching avalanche that tactical superiority couldn't stop. The escalation. Intelligence dismissed the initial reports as isolated incidents reflecting local tactical errors rather than systematic American capability. Kramer reviewed 3 separate engagement reports from late March 1943, each describing American M3 half-tracks achieving unexpected tactical success through speed and aggressive dismounted assault. Inexperienced units compensating for lack of skill through reckless advance, his analysis concluded. Such tactics succeed against surprise defenders but fail against prepared positions. American forces will learn this through casualties. The assessment reflected professional military judgment based on European experience where vehicle mobility enabled maneuver but didn't substitute for tactical skill. German doctrine emphasized combined arms coordination, prepared defenses, and methodical advance. American doctrine apparently emphasized rapid movement and immediate assault. History suggested the German approach would prevail. Mathematics suggested otherwise. Von Browich reported to Oberkommando der Wehrmacht in early April with updated production intelligence and tactical assessments. American half-track production reached 1,412 units in March 1943. This exceeds our annual SD, KFZ, 251 production. Single facilities are producing more vehicles than our entire industry. White Motor Company, 347 units in March. Autocar Company, 296 units. International Harvester, 384 units. Diamond T, 385 units. Combined monthly output exceeds our total war production to date. Requests strategic assessment of implications for force ratios in Mediterranean theater. His report included projections showing American forces achieving 3-to-1 numerical superiority in half-tracks by June 1943, 5-to-1 by September, 8-to-1 by December. The projections assumed current production rates without acceleration. American production statistics from intercepted logistics documents confirmed the escalation. Monthly half-track output, January 1943, 1,087 units. February 1943, 1,274 units. March 1943, 1,412 units. April projections, 1,600 units. German production for comparison, January 1943, 47 SD, KFZ. 251 half-tracks. February 1943, 53 units. March 1943, 61 units. April projections, 68 units. A single American facility, White Motor Company's Cleveland plant, exceeded entire German half-track production by a factor of 5. The 4 primary American facilities combined exceeded German production by a factor of 23. The mathematics were becoming undeniable. Germany couldn't win a war of industrial attrition against an enemy that produced vehicles faster than combat could destroy them. They tried modifying tactics to counter American mobility advantage. German forces established deeper defensive positions with interlocking fields of fire, forcing American half-tracks to slow during approach. The Americans called in artillery and advanced through the bombardment. German forces positioned anti-tank weapons to engage approaching vehicles at maximum range. The Americans deployed smoke and overwhelmed defensive positions through local superiority before repositioning. German forces attempted ambush tactics, allowing American vehicles to penetrate positions before engaging. American infantry immediately dismounted and assaulted, accepting casualties to eliminate German positions. German forces tried night movement to avoid American firepower. American forces used vehicle-mounted searchlights and night vision equipment to maintain operational tempo. Every tactical adjustment met systematic response enabled by material abundance. If smoke was needed, Americans expended it lavishly. If searchlights were needed, every vehicle carried one. If artillery support was needed, American radios called it in without regard to ammunition expenditure. April 7, 1943, Hill 609, Tunisia, 14:23 hours. Elements of the 1st Infantry Division attacked prepared German positions using 43 M3 half-tracks carrying 430 infantry. The engagement demonstrated the transformation of American tactical doctrine. At 14:23 hours, American artillery began preparatory bombardment. At 14:37 hours, 14 minutes later, 43 M3s advanced at 40 miles per hour directly into the impact zone while artillery was still firing. At 14:42 hours, the vehicles penetrated German forward positions without slowing. At 14:44 hours, 430 American infantry dismounted under fire and immediately assaulted. At 14:48 hours, 4 minutes after dismounting, American forces had overrun the first defensive line. At 14:53 hours, 9 minutes after initial contact, American forces controlled the objective. Total engagement duration: 30 minutes from artillery start to objective secured. German losses at Hill 609. 143 personnel killed or wounded, 67 captured, 4 anti-tank guns destroyed, 2 SD, KFZ. 251 half-tracks disabled, defensive positions overrun. American losses: 19 killed, 47 wounded, 2 M3 half-tracks damaged by mines, 0 vehicles destroyed. Kill ratio for vehicles: 0, 2 in favor of supposedly inferior American equipment. The ammunition expended in this 30-minute engagement exceeded the monthly allocation for an entire German infantry division. American forces fired approximately 18,000 rounds of 50 caliber ammunition, 460 rounds of 75mm artillery, 6,000 rounds of 60mm mortar, and approximately 150,000 rifle rounds. German divisions received monthly allocations calculated to sustain defensive operations for 30 days. 8,000 rounds of 20mm ammunition, 200 rounds of 75mm artillery, 36,000 rifle rounds. Americans had exceeded German monthly rifle ammunition allocation by a factor of 4 in a single 30-minute engagement while attacking, not defending. The fuel consumed in this engagement, approximately 3,000 gallons for vehicles and generators, exceeded German weekly allocation for an entire motorized battalion. Von Browich presented engagement analysis to division headquarters on April 10. American forces are achieving systematic tactical success through material superiority that compensates for training deficiencies. Their half-tracks enable rapid concentration of force before we can establish defensive coordination. Their artillery expenditure exceeds our defensive capabilities. Their willingness to accept casualties during assault eliminates our advantage in prepared positions. Most critically, their production capacity ensures that vehicle losses don't degrade operational capability. They lost 2 M3 half-tracks at Hill 609. American factories produced 274 M3s on April 7, the same day as the engagement. One day's production replaces 137 engagements at Hill 609 loss rates. The mathematics indicate we cannot inflict sufficient losses to degrade American operational capability while our losses are irreplaceable. The analysis was professionally presented, mathematically sound, and strategically devastating. Kramer read it carefully, acknowledged the production figures, and nevertheless maintained that combat effectiveness would determine outcomes. Material superiority is meaningless against superior training and doctrine. Another battle at Segenane on April 18 reinforced the pattern. 61 M3 half-tracks carried 610 American infantry against prepared German defensive positions defending a critical road junction. The engagement followed the new American template: massive artillery preparation, rapid vehicle advance during bombardment, immediate dismounted assault. At 9:23 hours, artillery began. At 9:36 hours, 13 minutes later, M3s penetrated the impact zone. At 9:39 hours, 3 minutes after that, infantry dismounted. At 9:43 hours, 4 minutes after dismounting, American forces controlled the objective. Total engagement time, 20 minutes. German losses: 97 personnel casualties, 112 captured, defensive positions overrun. American losses: 32 casualties, 1 M3 damaged. The pattern was becoming systematic. American forces sacrificed tactical finesse for material overwhelming. They didn't outmaneuver German positions. They drove through them accepting casualties that their production capacity made sustainable while inflicting losses that German production couldn't replace. April 23, 1943, Longstop Hill, Tunisia, 15:34 hours. 29 M3 half-tracks from the 34th Infantry Division approached German positions using terrain masking that doctrine said was impossible for vehicles. The engagement demonstrated the evolution of American tactical employment beyond simple frontal assault. At 15:34 hours, lead vehicles identified German positions from 2,000 meters. At 15:47 hours, 13 minutes later, M3s had closed to 800 meters using reverse slope approach. At 15:51 hours, 4 minutes after that, vehicles crested final ridgeline and immediately received fire from 3 German positions. At 15:52 hours, 1 minute later, American vehicles dispersed and returned fire while continuing to advance. At 15:54 hours, 2 minutes after initial contact, all 29 vehicles had discharged 290 infantry who immediately assaulted. At 15:59 hours, 5 minutes after dismounting, first German position was overrun. Elapsed time from initial contact to first objective, 7 minutes. At 16:04 hours, 5 minutes later, second position fell. At 16:11 hours, 7 minutes after that, third position was eliminated. Total engagement duration, 37 minutes. German losses, 47 killed, 83 captured, 3 anti-tank guns destroyed. American losses, 12 killed, 29 wounded, 0 vehicles destroyed. Kill time per defensive position averaged 6 minutes from assault initiation to position elimination. Dietrich observed this engagement from German second-line positions and filed detailed after-action analysis. American forces have developed systematic doctrine for M3 employment that maximizes vehicle mobility while minimizing vulnerability. They use terrain intelligently, advance under covering fire, dismount at optimal range, and assault immediately with coordinated fire support. The vehicle serves as mobile fire platform during approach, personnel carrier during final advance, and supporting weapons system during assault. Their 50 caliber machine guns suppress defensive positions while infantry maneuver. The combination creates overwhelming local firepower that German defensive positions cannot match without armor support. Most critically, they execute this doctrine consistently across multiple units, indicating systematic training rather than isolated tactical innovation. American forces are learning faster than we can adapt because their material abundance permits doctrinal experimentation without resource penalty. We must conserve vehicles. They can test approaches and accept losses because replacement production is continuous. The analysis reached division headquarters on April 25. Kramer noted in margins, improved tactics don't compensate for material inferiority. The mathematics of the engagement suggested otherwise. 0 vehicles destroyed, objective secured in 37 minutes, enemy forces eliminated at 6-minute intervals. The ammunition expended at Longstop Hill exceeded German monthly allocation for an entire infantry regiment. American forces fired approximately 11,000 rounds of 50 caliber ammunition during the 37-minute engagement, averaging 297 rounds per minute of sustained fire. German infantry regiments received monthly allocations of 8,000 rounds of machine gun ammunition calculated to sustain defensive operations for 30 days. Americans expended more in 37 minutes than Germans allocated for 30 days, demonstrating operational philosophy where ammunition was treated as unlimited resource rather than carefully rationed supply. Artillery support for Longstop Hill included 160 rounds of 75mm high explosive, 87 rounds of smoke, 43 rounds of illumination. German artillery battalions received monthly allocations of 120 rounds of 75mm ammunition for all purposes. Americans exceeded German monthly artillery allocation in single 37-minute engagement, while German forces carefully rationed every round. The fuel consumed transporting 29 M3 half-tracks to objective, conducting assault, and returning to assembly area totaled approximately 800 gallons. German mechanized battalions received weekly fuel allocations of 600 gallons. One American company operation exceeded one German battalion's weekly fuel allocation, demonstrating logistical abundance that enabled operational tempo German forces couldn't match. Recognition arrived incrementally through accumulating evidence rather than single revelation. Von Browich compiled engagement reports from March 23 through April 18, 17 separate actions where American M3 half-tracks achieved tactical success against prepared German positions. Average engagement duration, 26 minutes. Average American vehicle losses, 1.3 M3s per engagement. Average American casualties, 47 personnel. Average German personnel losses: 123 killed, wounded, or captured. Average German vehicle losses: 2.1 armored vehicles. The statistics indicated systematic effectiveness rather than isolated success. More critically, the replacement mathematics were catastrophic. German forces lost 2 vehicles per engagement with monthly replacement production of 60 units. American forces lost 1.3 vehicles per engagement with daily replacement production of 137 units. 1 month of German replacement production supported 30 engagements. 1 day of American replacement production supported 105 engagements. The war had become a mathematical exercise where industrial capacity determined tactical capability, and German forces were solving the wrong equation. Command finally understood the implications, though understanding changed nothing. Oberkommando der Wehrmacht acknowledged in late April that American half-track production exceeded German capacity, but maintained that tactical skill and defensive preparation would enable continued resistance. The assessment was technically accurate. Properly prepared German positions could still inflict disproportionate casualties on attacking American forces. The assessment was strategically irrelevant. Americans could afford disproportionate casualties because they replaced losses faster than combat generated them, while German losses were permanent. Kramer still refused to believe that quantity could overcome quality, even as the evidence accumulated in engagement reports, casualty statistics, and captured enemy documents. Professional soldiers using professional equipment will defeat amateurs in quantity-produced vehicles, he maintained. Dietrich observed the destroyed German vehicles being replaced 1 per month, while observing destroyed American vehicles being replaced 3 per day, and stopped arguing with conclusions that mathematics had already disproven. The production avalanche. At White Motor Company's Cleveland facility, the assembly line achieved 117 seconds per vehicle by April 1943. Every 117 seconds, another M3 half-track rolled off the line, was driven to inspection, was tested, was approved, and was shipped to port for transport to combat theaters. This single facility produced more than Busing NAG, Hanomag, and Deutsch work combined. Cleveland plant operated 3 shifts covering 23 hours daily, allowing 1 hour for maintenance. Daily output: 689 minutes of production divided by 117 seconds per vehicle equals 353 vehicles weekly. Monthly output at this single facility: 1,412 M3 half-tracks. Germany's entire half-track industry produced 68 SD, KFZ, 251s in April 1943. One American facility produced vehicles at a rate 20.7 times greater than Germany's entire military-industrial capacity, allocated to half-track production. Americans discarded transmission assemblies that failed initial testing without attempting repair. Each discarded transmission represented 47 components, 18 pounds of steel, 6 pounds of aluminum, 173 minutes of assembly labor. Weekly discards at Cleveland: 47 transmissions that failed acceptance testing for noise, vibration, or specification deviation that German facilities would have diagnosed and repaired. German facilities couldn't discard components because material allocations were calculated for zero waste. Every transmission underwent testing, diagnosis, and component replacement until it met specifications. The repair process required skilled mechanics who understood transmission function. American facilities discarded transmissions and scheduled replacement production because the cost of skilled mechanics exceeded the cost of replacement manufacturing at volume. The transmissions that Cleveland discarded weekly exceeded Germany's entire monthly transmission production capacity for SD, KFZ. 251 vehicles. One American facility's waste exceeded one nation's maximum output. Workers threw away cutting tools after 4 hours of use that Germans maintained for 4 months. Carbide cutting tools cost $47 each, equivalent to 2 weeks of German skilled worker salary. American facilities replaced cutting tools on time-based schedules regardless of actual wear, because maintaining sharp tools was cheaper than employing skilled workers to judge tool condition and adjust machining parameters. Weekly cutting tool disposal at Autocar's Ardmore facility: 860 tools discarded on schedule. German facilities issued cutting tools to individual machinists who maintained personal sets, sharpening and adjusting them through entire careers. The cutting tools that Autocar discarded weekly would have equipped 6 German manufacturing plants operating for 1 year. Americans treated $47 cutting tools as consumable supplies. Germans treated them as capital equipment requiring skilled maintenance. The difference reflected abundance versus scarcity, and abundance was winning. The cafeteria at International Harvester's Fort Wayne facility discarded food that exceeded the caloric value of German military rations for an entire division. Daily food waste from 8,000 workers, 1,200 pounds including uneaten meals, expired ingredients, preparation waste, and spoilage. Weekly waste, 8,400 pounds. Monthly waste, 33,600 pounds. A German infantry division of 17,000 personnel received daily rations totaling 11,000 pounds of food at standard allocations. 200 grams bread, 40 grams meat, 15 grams fat per person daily. The Fort Wayne cafeteria's monthly waste exceeded 3 days of rations for an entire German division. American industrial workers received unlimited coffee, subsidized hot meals, and free fruit to maintain productivity. German military forces received precisely calculated rations to sustain combat effectiveness. American abundance manifested in cafeteria waste that represented more calories than German soldiers received as complete daily rations. The coffee grounds that Fort Wayne discarded weekly contained more calories than the meat rations allocated monthly to a German infantry battalion. Aluminum scrap from Diamond T's Chicago plant exceeded Germany's monthly aluminum allocation for all military half-track production. Quality control rejected engine blocks, transmission housings, and structural components for minor flaws that didn't affect function but failed stringent acceptance criteria. Weekly aluminum scrap at Chicago, 2,300 pounds from rejected castings. Monthly total, 9,200 pounds of aluminum alloy discarded as scrap and sold to commercial recyclers. Germany's entire monthly aluminum allocation for SD, KFZ. 251 production, 8,100 pounds. One American facility generated more aluminum scrap than Germany allocated to its complete military half-track program. The rejected components would have built 143 German half-tracks if German engineers had accepted them. American engineers rejected them because replacement production cost less than the risk of field failures. The mathematics of abundance permitted waste that the mathematics of scarcity made unthinkable. Discarded ammunition from acceptance testing exceeded German combat allocation for an entire armored division. Each M3 half-track underwent weapons testing before acceptance, 100 rounds of 50 caliber ammunition per vehicle to verify mounting, accuracy, and function. Daily ammunition expenditure for testing at Cleveland alone, 37,000 rounds. Weekly, 259,000 rounds. Monthly, 1,048,000 rounds expended purely for testing, not combat. German armored divisions received monthly ammunition allocations calculated to sustain defensive operations. 600,000 rounds of 20mm ammunition, 300,000 rounds of rifle ammunition, 48,000 rounds of machine gun ammunition. The ammunition that one American testing facility expended monthly exceeded the complete small arms allocation for a German armored division. Americans tested every vehicle with 100 rounds because testing cost less than field malfunctions. Germans allocated ammunition by the round because production capacity limited supply. One industrial philosophy assumed abundance and optimized for reliability. The other assumed scarcity and optimized for conservation. The war was demonstrating which philosophy prevailed. Paint waste from White Motor Company exceeded Germany's entire monthly paint allocation for military vehicle production. Each M3 received 3 coats of olive drab paint applied by automated spray systems that wasted approximately 40% of paint as overspray. Daily paint waste at Cleveland, 280 gallons of military specification paint. Weekly, 1,960 gallons. Monthly, 7,840 gallons discarded as overspray, expired inventory, and contaminated batches. Germany's entire monthly allocation of military vehicle paint, 6,200 gallons shared across all armor production facilities. One American plant's paint waste exceeded Germany's total military vehicle paint supply. The discarded paint could have finished 1,400 German half-tracks if German logistics could have captured and distributed it. American facilities optimized for speed and consistency using automated spray systems that wasted paint, but eliminated the skilled painters that German facilities required. This single aspect of American industrial abundance exceeded German production capacity. Waste from automation exceeded output from craftsmanship. Rejected tires from International Harvester totaled more rubber than Germany allocated annually to its entire half-track program. Quality control rejected tires for tread defects, sidewall irregularities, or dimensional variations that didn't affect function but failed specification. Each M3 required 5 tires, 4 running wheels and 1 spare. Weekly tire rejections at Fort Wayne, 314 tires discarded for quality failures. Monthly, 1,256 tires representing 2,800 pounds of rubber. Germany's annual rubber allocation for SD, KFZ. 251 production, 28,000 pounds, sufficient for 1,867 complete vehicle sets at 15 pounds per tire. International Harvester's monthly tire waste, 2,800 pounds, represented 10% of Germany's annual rubber allocation for half-tracks. Americans discarded tires that German forces would have used until tread was completely worn, then retreaded and used again. The rejected tires from one American facility in 1 month could have equipped 251 German half-tracks, more than 4 months of complete German production. This single facility's quality control waste exceeded Germany's quarterly production capacity. Electrical components discarded for minor defects exceeded Germany's monthly production of complete wiring harnesses. Each M3 required comprehensive electrical system: lighting, starting, ignition, instruments, communications. Quality control tested every component and rejected any showing irregular performance even if functional. Weekly electrical component waste at Auto Car: 1,473 items including generators, starters, voltage regulators, light assemblies, switches. Monthly, 5,892 components discarded. Germany's monthly production of complete SD, KFZ. 251 wiring harnesses, 68, 1 per vehicle. Autocar discarded 86 times more electrical components monthly than Germany produced complete electrical systems. The discarded generators alone, 743 monthly, exceeded 10 months of German half-track production. Americans replaced marginal components because the cost of field electrical failures exceeded component cost. Germans repaired every component because allocations assumed zero waste. American quality control optimization generated more waste than German production generated output, demonstrating industrial capacity so abundant that waste exceeded competitors' maximum production. Von Browich documented these comparisons in his May intelligence summary, submitted to Oberkommando der Wehrmacht. His report included detailed calculations showing that American industrial waste exceeded German military production across multiple categories. Steel scrap from one facility exceeded total German allocation. Aluminum scrap from one facility exceeded complete program allocation. Ammunition testing exceeded divisional combat allocation. Food waste exceeded divisional rations. His summary concluded, American industrial capacity has transformed warfare from contest of skill to contest of resources. Our tactical advantages are becoming strategically irrelevant against an enemy that produces faster than we can destroy, wastes more than we can produce, and treats as consumable what we treat as irreplaceable. The mathematics indicate that continued resistance depletes irreplaceable German resources while engaging enemy resources that regenerate faster than combat consumes them. The report was mathematically rigorous, professionally presented, and completely accurate. It was also filed without action because acknowledging these conclusions required abandoning strategic assumptions that had guided German planning since 1939, that quality defeated quantity, that professional armies defeated industrial mobilization, that tactical excellence defeated material superiority. The mathematics contradicted these assumptions. German command chose to trust assumptions rather than mathematics. History would validate the mathematics. Systematic annihilation. May 6, 1943, final offensive, Tunisia. 234 M3 half-tracks carrying 2,340 American and British infantry faced 900 German defenders in prepared positions, protecting the final defensive line before Tunis. The engagement lasted 2 hours 17 minutes from initial artillery preparation to objective secured. The mathematics of material superiority eliminated tactical nuance and reduced combat to industrial process. Identify objective. Apply overwhelming firepower. Advance mechanized infantry. Accept casualties. Repeat. At 6:47 hours, Allied artillery began preparatory bombardment using 123 guns firing for 47 minutes. At 7:34 hours, while artillery was still firing, 234 M3 half-tracks advanced at 43 miles per hour directly into impact zone. At 7:41 hours, 7 minutes after beginning advance, lead vehicles penetrated German forward positions. At 7:44 hours, 3 minutes after penetration, 2,340 infantry dismounted under fire. At 7:49 hours, 5 minutes after dismounting, first defensive line was overrun. Minute-by-minute breakdown documented the transformation of combat into mechanical process. At 7:49 hours, 93 German defenders in forward positions were killed, wounded, or captured. At 7:56 hours, 7 minutes later, 126 defenders in second line were eliminated. At 8:03 hours, 7 minutes after that, 147 defenders in third line were overrun. At 8:11 hours, 8 minutes later, final defensive positions were penetrated. At 8:23 hours, 12 minutes after that, organized resistance ceased. At 9:04 hours, 41 minutes later, objective was secured and consolidated. Total engagement duration from first artillery round to objective secured, 2 hours 17 minutes. Average time to eliminate each defensive position, 17 minutes. German forces inflicted casualties through prepared positions and accurate fire, but couldn't inflict losses faster than American material superiority could absorb them. 234 vehicles and 2,340 infantry created local superiority of 6-1 at each defensive position, overwhelming defense through volume rather than tactical excellence. Enemy aircraft destroyed. German Luftwaffe attempted ground support missions using 31 Ju-87 Stuka dive bombers and 16 Bf-109 fighters. At 8:17 hours, Luftwaffe aircraft approached to attack Allied vehicles. At 8:19 hours, 2 minutes later, Allied anti-aircraft fire from vehicle-mounted weapons engaged. At 8:23 hours, 4 minutes after initial engagement, 7 Ju-87s were destroyed. Kill time per aircraft, 34 seconds average. At 8:28 hours, 5 minutes later, 4 more Ju-87s destroyed. Kill time per aircraft, 43 seconds average. At 8:34 hours, 6 minutes later, 3 Bf-109s destroyed. At 8:41 hours, 7 minutes later, organized air attack ceased. Total Luftwaffe losses, 14 aircraft destroyed, 6 damaged. Allied losses from air attack: 0 vehicles destroyed, 4 damaged, 11 personnel casualties. The 50 caliber machine guns mounted on M3 half-tracks, which German intelligence had dismissed as inadequate defensive armament, proved effective against low-altitude ground attack aircraft. Kill ratio for air combat: 14-0 in favor of supposedly defensive weapons used offensively by untrained personnel. The ammunition expended in anti-aircraft fire exceeded German monthly allocation for an entire anti-aircraft battalion. American losses from the entire engagement: 83 killed, 247 wounded, 17 M3 half-tracks destroyed or disabled. German losses: 547 killed or wounded, 353 captured. Kill ratio for personnel: 1:7, 1 in Germany's favor, which under previous doctrine would indicate tactical success. Kill ratio became irrelevant when replacement capacity was factored. American casualties would be replaced within 1 week from personnel pools in North Africa. American vehicle losses would be replaced within 1 day from production output. German casualties were irreplaceable. German vehicle losses were permanent. The final mathematics demonstrated the transformation. Germany traded irreplaceable forces for temporary tactical advantage, while American forces traded replaceable resources for permanent strategic advance. The fuel consumed in this engagement, approximately 14,000 gallons for vehicles, generators, and equipment, exceeded German weekly allocation for an entire armored division. The ammunition expended, approximately 94,000 rounds of 50 caliber, 600 rounds of artillery, 14,000 rounds of mortar, exceeded German monthly allocation for an entire corps. At 8:47 hours, 43 minutes into the engagement, Generalmajor Hans Kramer was directing defensive artillery when his command vehicle was struck by Allied fire. Elapsed time from engagement to his wounding: 43 minutes. Kill time from initial targeting to casualty, approximately 9 seconds based on observer reports. Kramer survived with severe leg wounds but could no longer command. He was captured 3 days later when remaining German forces surrendered at Tunis. In captivity, he would write extensive reports analyzing the North African campaign, including detailed assessment of how German forces had underestimated American industrial capacity. His analysis would note that tactical superiority became strategically irrelevant when the enemy could replace losses faster than combat generated them. The mockery he had expressed examining captured M3 half-tracks on March 17 would be referenced in his own analysis as example of how professional military assessment failed to account for industrial mobilization on unprecedented scale. History's judgment would be more concise. Kramer had brought expertise to a production contest. German prisoner testimony after the May 13 final surrender at Tunis described combat as systematic annihilation rather than warfare. Captured officers reported that Allied forces didn't maneuver tactically, but simply advanced with overwhelming firepower until resistance ceased. This wasn't combat between professional forces, one battalion commander stated during interrogation. This was industrial process applied to military objectives. They identified defensive positions, applied artillery until positions were suppressed, advanced vehicles carrying infantry, dismounted forces assaulted immediately, repeated the process at the next position. There was no tactical finesse, no maneuver, no exploitation of weakness, just systematic application of material superiority until we were eliminated. The description was accurate. American forces had converted warfare from art to engineering, from tactical skill to industrial logistics, from professional contest to production race. The transformation rendered German professional advantages irrelevant because Americans weren't trying to outfight German forces. They were trying to outproduce German industry while applying sufficient force to ensure production advantage translated to battlefield superiority. The strategy succeeded. Capitulation. June 1943. Allied Interrogation Facility, Algeria. Oberstleutnant Friedrich von Broich sat across from Allied intelligence officers providing detailed analysis of German assessment failures. We were not defeated by better soldiers, but by better factories. Your M3 half-track was inferior to our SD, KFZ. 251 in every measurable specification. Thinner armor, less powerful engine, cruder manufacturing. But specifications became irrelevant when you produced 20 for everyone we manufactured. At Hill 609, we destroyed 2 of your vehicles and considered it tactical success. You replaced both vehicles the same day from daily production output. We couldn't replace our losses for weeks. By May, you were fielding 6 M3s for every one of our half-tracks. By war's end, the ratio would reach 13-1. Individual vehicle quality doesn't determine outcomes when one side produces an order of magnitude more vehicles than the other. A single American factory, White Motor Company in Cleveland, produced more half-tracks than our entire industrial capacity allocated to the program. We optimized for quality. You optimized for quantity. The war validated your approach. Hauptmann Klaus Dietrich, recovered from wounds sustained during the final collapse, provided tactical assessment. I saw the M3 half-track evolution from March through May. Initially, your forces used them as simple transport, vulnerable and poorly coordinated. By April, your doctrine had evolved. Vehicles advanced during artillery bombardment, infantry dismounted and assaulted immediately, overwhelming local defenses through speed rather than tactical finesse. By May, your forces conducted systematic operations where the M3 served as mobile assault platform that converted numerical superiority into tactical dominance. The vehicle itself didn't improve, but operational employment did. You learned faster than we could adapt because you had material abundance that permitted experimentation. We had to conserve resources. You could afford to test approaches, accept losses, and refine doctrine through iterative improvement. The Americans didn't just outproduce us. They revolutionized production itself, converting manufacturing from craft to industrial process that eliminated skilled labor bottlenecks and enabled geometric production increase. We required 186 labor hours per vehicle. You required 92. We required skilled welders trained over years. You required semi-skilled workers trained in weeks using templates that embedded expertise in tooling rather than workers. Additional testimonies revealed systematic underestimation across German command structure. We brought professional military competence to a production contest, one captured general stated. We analyzed your M3 half-track and correctly identified every material deficiency. We failed to analyze your industrial capacity and completely misunderstood strategic implications. Your half-track was inferior. Your factories were superior. In total war, factories matter more than individual equipment quality. Another officer noted. Their excess capacity exceeded our maximum effort. We calculated that German industry fully mobilized could produce 68 half-tracks monthly. A single American facility produced 347. The mathematics demonstrated different industrial philosophies. We optimized existing capacity, you built new capacity. We conserved resources, you generated resources. We treated industrial production as constraint. You treated it as variable that could be increased through investment. German prisoners emphasized replacement mathematics in multiple testimonies. They could lose 137 M3 half-tracks and replace them in one day. We lost 2 SD, KFZ, 251s and required 1 month to replace them. This ratio meant that tactical victories became strategically irrelevant. At Hill 609, we inflicted 2-to-1 personnel casualties and considered it successful defense. They replaced their casualties within 1 week. We couldn't replace ours for months. By June, American forces in North Africa operated 4,700 M3 half-tracks. German forces operated 360 half-tracks of all types. The ratio was 13-to-1 in their favor. Individual engagements where we achieved tactical success didn't matter when strategic force ratios ensured their next attack would succeed through overwhelming numerical advantage. The testimony included precise calculations. They produced sufficient M3s in 6 weeks to replace every vehicle they lost in the entire North African campaign. Our total war production of SD, KFZ, 251s through May 1943 was 3,100 vehicles. Their production in the same period was 14,300 M3s. The mathematics were absolute. They outproduced us by factor of 4.6 while engaged in simultaneous campaigns in Pacific, maintaining production of multiple other vehicle types, and expanding industrial capacity for future operations. Production statistics confirmed by captured documents revealed American industrial transformation. American production of M3 half-tracks by year: 1941, 2,407 units. 1942, 12,836 units. 1943, 21,743 units. 1944, projected 31,000 units. Total war production through 1945, 41,155 M3 and related variants. German production for comparison, 1939 through 1945, 15,252 SD, KFZ, 251 half-tracks total. Single American facility peak production. White Motor Company produced 463 M3s in July 1943. That single month at one facility exceeded entire German production for any quarter of the war. Entire German SD, KFZ, 251 program, 4 primary manufacturers, peak monthly output 93 units in December 1944. 4 American M3 facilities combined, peak monthly output 2,347 units in September 1943. The production ratio reached 25-to-1 at peak, demonstrating industrial capacity difference that tactical excellence couldn't overcome. The lesson: the M3 half-track proved that democratic industrial mobilization outproduced authoritarian military efficiency when properly organized. Free workers at White Motor Company's Cleveland plant, earning union wages and working regulated hours, produced more military vehicles than Germany's entire controlled economy allocated to comparable programs. Democratic cooperation between labor unions, corporate management, and government coordination exceeded totalitarian command systems that subordinated all economic activity to military objectives. Industrial abundance, generated by market economics converted to war production, buried ideological superiority under measurable output. 41,000 American half-tracks versus 15,000 German half-tracks. The disparity reflected systemic advantages in democratic capitalism that converted peacetime productive capacity to wartime industrial output through cooperation rather than coercion. Workers who volunteered for defense production outproduced workers conscripted for military manufacturing. Companies competing for defense contracts innovated faster than state-controlled industries operating by directive. Engineers free to optimize production developed more efficient methods than engineers constrained by ideological requirements. March 17, 1943. General Major Hans Kramer had laughed at the American M3 half-track, dismissing it as commercial product rushed into military service. May 13, 1943. Kramer surrendered at Tunis along with 192,000 German and Italian personnel, having learned that industrial capacity determined strategic outcomes regardless of tactical excellence. Their mockery became history's most expensive miscalculation, measured in a campaign that cost Axis forces 252,000 casualties and ended Axis presence in North Africa. The M3 half-track, dismissed as inferior by every professional military metric, transported Allied forces through North Africa, Sicily, Italy, France, and Germany, serving longer and in greater numbers than any competing design because American industry had converted warfare from tactical contest to production race. The production statistics remained historically unmatched. 41,000 American half-tracks versus 15,000 German half-tracks represented a 2.7-to-1 advantage in pure numbers. The advantage compounded when replacement rates were factored. American industry could replace total vehicle losses every 17 days, while German industry required 4 months. The M3's material inferiority became strategically irrelevant when American factories produced replacements faster than combat destroyed them, while German losses remained permanent. Rommel, who had captured M3 half-tracks at Kasserine Pass and tested them at 45 miles per hour, reportedly demanded 500 for his Panzer divisions, because he recognized that the vehicle's tactical deficiencies were overcome by strategic abundance. His request was denied not because the M3 was inadequate, but because German industry couldn't replicate American production methods. Standardized components, interchangeable parts, automated assembly, unskilled labor using powered tools, and continuous process improvement that reduced per-unit labor from 186 hours to 92 hours through engineering rather than worker exploitation. The lesson remains: dismissing democratic nations as weak because they prefer peace or underestimating free people's productive capacity invites catastrophic miscalculation. Industrial mobilization in democratic systems, when properly motivated, generates material superiority that overwhelms tactical advantages through systematic application of resources. Professional militaries achieve tactical excellence. Democratic societies achieve industrial dominance. In total war, industrial dominance determines strategic outcomes because tactics address individual engagements, while production determines cumulative capacity. German forces won tactical victories throughout the North African campaign, while losing strategically because American factories produced faster than German forces could destroy, creating mathematical certainty that replaced military uncertainty. The M3 half-track, inferior by every professional specification, proved that free peoples properly organized for industrial warfare defeat authoritarian systems optimized for military efficiency through the simple mathematics of abundance. Producing more, wasting more, and replacing more comprehensively defeats producing less, conserving more and replacing slowly regardless of individual component quality.